Greetings, fellow humans. It's GaySarahK back at it again with Human Resource Machine. Now, to be completely honest, I may have played this game a little bit offline, but I wanted to give myself some extra time to kind of think about some of these levels. And I also wanted to go ahead and play some of the optional levels as well. Tripler Room, Octuplier Suite, and then the Tetracontiplier. Essentially what these were is, given an input, you're supposed to triple it, or octuple it, or tetracontiply it. Which apparently means that you multiply it by 30. No, not 30, 40. And I had a little bit of fun with that. The tripler, because you don't have access to a multiplication command. There's no way to multiply numbers. All you can do on this level is just add them. So how do you triple a number? And the answer is you add it twice to itself. And so that is precisely what this loop does. It takes the 7, places it down, adds 7 to it twice, output. Takes the -2, puts it down, adds -2 twice, puts that in the outbox. Does the same with 1, does the same with 0. I could have put in a small optimization, but as for whether that would have actually been better, hard to say. Either way, with this solution, I was able to get both challenges done simultaneously, and because these are, it's exactly 6 and it's exactly 24, I think it's safe to say that this is the exact solution that they had in mind. Octuplier Suite. Interestingly enough, I don't simply add 7 times because that's wasteful. What I do, well, they say wasteful, maybe not the word I would have picked. But what this one does is it takes the 6, puts it down, adds, then puts that down, adds that, puts that down, and adds that. So what you end up with is it actually doubles the number 3 times, resulting in a total of times 8. And once again, it does the same thing with 0 as well, instead of simply, you know, jumping to the next thing, because why bother? This is the solution that they wanted me to use for this one as well. Multiplying by 40 is a little bit trickier, because 8 is a power of 2, so you can just double it, and then double it, and then double it. Multiplying by 40, it's not quite that simple. So what I did was first I multiplied by 5, and then I doubled and doubled and doubled. And as for how you multiply by 5, well, I actually copied it to 0, then added and copied that to 1, then doubled it, and added it back to what's stored here. Then I put it over here, and I doubled it 3 times. And that comes out to a total multiplication of 40. See, it's important to understand how multiplication works if you're trying to multiply through adding. And this is generally something that software engineers like myself have to understand. And once again, you find that the size is perfect and the speed is perfect. I'm actually interested in knowing, oh, right, there is no jump if zero command. I haven't unlocked it yet at this point in the game. So I actually can't add the jump if zero optimization, even if I wanted to. Exclusive lounge. I don't recall even looking. Oh, right. Yeah, I did look at this one, I just never completed it. Because I'm supposed to take in 2 numbers. Wait, no. I did complete this one, I just didn't do either of the challenges. Which is a little strange, because I would have thought that this would have been fully optimized in terms of time. But yeah, inbox, jump if negative, jumps to here, inbox, jump if negative, jumps to here. If they're both the same sign, I'm not sure. Did I ever complete this one? Yeah, those have different signs, so it outputs 1. Those have the same sign, so it outputs 0. Those have the same sign, so it outputs 0. And it's really that simple, it just uses jump if negative, jump if negative. Now, the size was not optimized, and weirdly enough, neither was the performance. Let's see. Yeah, this jump command. And this jump command, jump if negative. Right. So this jump command takes it down here. But what I could do is I could put that there. Well, I'll put it there for right now. Take that, put it there, and take this jump and put it there as well. And you see that this jump if negative and this jump, right, this jump pointed down here. This jump if negative came down here as well. So what I want to do is I just want to put them back. Copy from, outbox, and then jump. So now this jump, completely useless. And this jump if negative should go back over here. And I should move this comment as well. And I think that will improve the performance slightly, because that means that it won't have to jump to go down there just to jump back up. And sure enough, I got the speed challenge in. There's some way to optimize this further so that it only uses 12 commands instead of 13, but I'm not going to bother doing that right now. I wanted to show off some of the other solutions that I came up with while I was offline. So the multiplication workshop, this allows me to label what's on the floor. And so I can just, I can set these labels to be whatever I want, and it basically just lets me name the places that are on the floor. And that helped me, you know, figure out, or at least it helps me remember. Now that I'm going back over this solution, I can see, okay, yeah, this is, you know, the first number, this is what I'm supposed to multiply it by, and this is the actual result. And so, maybe better to just show off what this program does. First, it takes that 0, puts it into the result. It takes the 9, puts it there, takes the 3, puts that there, adds 9 to the result, decrements times, that's bumped down, adds first to the result, bumps down times, adds 9 to the result, bumps down times, discovers that times has been reduced to 0, then grabs the result and outputs it, overwrites the result with 0 again, and sets up for the next iteration of the problem. Now it's actually pretty tricky, as it turns out. When either of the multipliers are 0, you need some special, logic for that. And, I can't say I distinctly recall why. Probably because if this number is 0, then when I, you know, bump it down, then it becomes -1. So the test, if it's 0, doesn't work. But here you can see that copy 2 times, right? Then jump if 0. And so I have to jump if 0 immediately, instead of putting the jump to 0 down here, which I might be inclined to do otherwise. Anyway, that is the nature of this particular solution to this particular problem. And as we can see, I managed to get the size challenge complete. But as for the speed challenge, this was not considered very fast. And frankly, yes, I never wrote another version of this to try to be faster. So that's just how it is. Zero terminated sum. For this one, the inbox has numbers, some of which are 0, and I am simply supposed to add them all up until I reach the 0, at which point I'm supposed to take the sum and output that. This one was a little bit cheeky, I think, because I had to... No, I didn't. But I copied from 5 into 0, just so that there would be a result here. Because this game freaks out if you try to interact with an empty box. So I have to copy this one over here, which is what these two commands do. Then I grab something from the inbox. If it's 0, then I simply copy it and put it into the outbox and we're done. Otherwise, I add it to whatever is here. If that number is 0, then, you know, I put the number down, right? Because anything plus 0 is itself. And then I copy it back down to here because that's, you know, what I do in order to track the sum. And then I jump back over here to where I grab from the inbox again and just continue doing that until the number I grab from the inbox is 0. And at that point, the whole thing basically starts over because all I have to do is copy that one, put it into the outbox, and we're done. 2 plus 6 is 8. And then I found a 0, so I just grab the 8, output that. I make sure to overwrite this because I don't want that 8 to still be sitting there as part of the previous. Now this one, this is where it gets a little tricky. Because as we see here, this number is 0. And so I have to output a 0. And that kind of threw me off at first. But in the end, this solution is relatively simple, elegant. But let's see how it scores. As you'll see, I used 10 commands, but it was a bit slower than it was supposed to be, at least ideally. Yes, this one. This one's the one I'm incredibly proud of. But I'll get to that in a minute. The littlest number. This one works similarly, but instead of addition, I'm supposed to find the smallest. So, of these 3 numbers prior to this 0, I'm supposed to return the smallest of the 3, which is this 1. So you can see that, you know, I take the number, I copy this next one down, I compare them. 1 minus 8 is negative, so I grab this one, put it down here, because it's the smallest number I found so far. Once I grab the 0, I just copy that over, you know, and we're all good. 19 minus 13, positive, don't care. 6 minus 13, negative, so we take the 6, move it over here. 3. 3 minus 6, negative, so we take the 3, copy it over here. And then we output 0. Or then we output 3. And here we're working with a relatively large number of relatively large numbers. But this algorithm doesn't care about that. It works fine regardless. It just finds the smallest number and outputs that. However, here I didn't match either of these challenges. Is there a way to optimize this one a little bit? Yep, here we have a jump if negative that all it does is jump over a jump command. But the jump command in turn, well, for one thing, it jumps to a jump, which is bad. Because jumping to a jump, you could just do that. And it would be 1 cycle faster. Which isn't a lot faster, but it's something. Here we copy from 1 to 0 because this is specifically the situation where the number is, the subtraction discovered that the number is smaller than it's supposed to be. Or than the previously found smallest one. That's a jump if 0, that's a jump if 0. And they both go to the same place. Well, that was a very small optimization, but I do believe that it was an optimization nonetheless. So let's go ahead and try that. That's still 15 commands, which is too many. But I do believe that what we see here is that this number is smaller than what it was. I think it was like 93? Not sure. Either way, it's a small, relatively minor improvement. Cumulative countdown. For each thing in the inbox, outbox the sum of itself plus all numbers down to 0. For example, if inbox is 3, outbox should be 6, because 3 plus 2 plus 1 equals 6. Now, I believe it was Gauss who found a really simple solution to this particular problem. For example, the story attributed to it is that he was in school, like grade school, and a teacher wanted to punish the class for something. And so she gave them the busy work of adding up every number up to 100. And so Gauss decided that he was going to simplify the problem. And essentially what he found is that 1 plus 100 is equal to 2 plus 99, which is equal to 3 plus 98, which is equal to 4 plus 97, which, you know, goes all the way to 51 plus 50. And so then he simply took 1 plus 100 and multiplied it by 50. And what he got, of course, is that the solution to the question that was given was 5050. And it's really a fairly simple thing here, but basically you just take the number that you're given and then you if it's even, no, what is it? Dadgummit. Right, you can add 1 and then multiply it by half of the number. And so what you end up with is like, yeah, 3 plus 1 is 4, and then half of 3 is 1.5. So you multiply 4 by 1.5 in order to get 6. 9, you can take 10, multiply that by 4.5, and get 45. 0 is just 0. And 6, you can take 7, multiply that by 3, get 21. So I said 6, 45, no. Is that what I said for 9? 45, 6, 45, and 21. And of course, if you watch this, it doesn't get to do what Gauss did, because there's no division. You can't divide numbers. Otherwise, it would be really simple. But you just can't divide by 2. Dang it, I forgot to actually look at the solution. But I'm sure that you'll find that I was correct in what I said. Unless I just messed up the math. But essentially, Gauss's solution is just so much faster than trying to do all of this crap by hand. And it works. And it doesn't just work for sums from 1. So, like, if it were adding up every number between 50 and 100, then you could say, you know, 100 plus 50 is 150. and then you multiply that by... Oh, I am not thinking straight right now. Right, the sum of all numbers from 50 to 100 would be... It's the same formula, right? It's the same principle. It's just that you take the larger number, you add the smaller number, you multiply by the difference between the two numbers, and then you divide everything by 2? Right. And then you multiply by the difference between the two numbers over 2. That's what you do. And it's kind of fascinating that there's, you know, that history behind this particular problem. But in the end, I wasn't actually able to use that to my advantage, because there's no way to divide by 2 in this game. That's the big limiter. That's the reason why I couldn't do it, is specifically because there's no way to divide by 2 in this game. Kinda sad. Here's a little bit of plot for people who were following the plot last time from the last video. So yes, it would certainly seem that the robots have taken over. Now this level, Fibonacci Visitor. I wasn't really able to get much done with this. If you need to ask for help, I'll be here looking through these catalogs for a golden spiral. Wow, I really did not get very far in this. But essentially what I'm supposed to do is output the entire Fibonacci sequence up to the number that I'm given for the input. So a number that, whatever number I have here, should not exceed that. Now this is just 1, which is the first number in the Fibonacci sequence. Okay. That was the main reason that was there. So what I would want to do is I would want to grab something from the inbox, copy it to that position, then I would want to copy from 0, add 1, actually, there we go. I can copy from 0, add 1, copy the result there. I'm going to call this cur, which is short for current. Computer science, that particular variable name is extremely common. It's like, I don't know exactly how common it is, but it's probably like one of the top 10 most common variable names ever. Maybe not, but kind of close to it. Essentially, it's just, it represents your current thing you're working on. I will also go ahead and name this one, I could have named, you know what, I'll name it slightly more descriptively. I will name this one Max, which in this case is short for maximum, and not, you know, Maximus or Maximilian or whatever else Max might be short for. And essentially, I will say, wait. I can copy that to current as well. And so then I can copy from current, add 1. Oh, right. Right. Because that's how the Fibonacci sequence works. Now, in actual programming, you can't name a variable cur -1 because the minus sign is not allowed as part of a variable name. But this isn't even text. This is literally drawn on here. So it doesn't matter. It doesn't matter in the slightest. Okay. So what I can do is I can actually copy this to cur -1 and then copy 1 to current. Inbox copy to max. Copy from cur, subtract max. If it's negative, I want to continue. Otherwise, I want to, yeah, I want to jump back up here. Or maybe just to be safe. Maybe I should do that. But if it's negative, Then I want to copy from current and I want to outbox. Then I want to copy from current -1, add current, copy it to just a random spot. It doesn't really matter. Then I want to copy from current, copy it to current -1, copy from the random spot, copy it to current, and then I can jump back into the loop. There, I think. Wait, no. Yes. So I subtract max. So let's try this. Let's see what happens. So it seems to be Fibonacciing correctly. So that's good. Wait, what? Right. So I subtract max. It's not negative. So it jumps there. Wait. Wait, what? Oh. That's worse. Okay. So I need to also include a jump if 0. Which is absolutely terrible. That number is positive, so it resets everything. Then it grabs a new maximum and starts the process all over again. And it continues to perform the Fibonacci sequence until it's done. Now there, I use more commands than I'm supposed to, and I do it in more cycles than I'm supposed to, but this is a challenge level. Mod module, small divide, 3 sort. The real thing that I wanted to end this on is storage floor, because I'm particularly proud of my solution for this level, because I utilized the power of computer science, the power of engineering, to completely wipe the floor with the record. Imagine each thing in the inbox is an address, and each address refers to a tile 0 through 9 on the floor. Your task for each address in the inbox, pick up the letter at that address and outbox. Okay, nope. That's not correct. That's not the level that I thought this was. This is an incredibly simple level that all it's doing is just, you know, all it's doing is just teaching you about indirect indexing. So I take the 6, I copy it into position 12, and because position 12 contained the value of 6, it then copied from position 6 instead of copying from position 12. And that's how it grabbed that O. And sure enough, if you continue on through here, there it grabs that A. And if you continue to play it, you see those little green arrows pointing to different things. Because this is how indirect indexing works. Sure enough, that one is correct. Maybe it was inventory report. Yes. This is the one. Because what I'm supposed to do is I'm supposed to take a thing in the inbox and send to the outbox the total number of matching items on the floor. Now, there's a lot of stuff on the floor, but we have A, B, C, and X. And something I realized is that the floor doesn't change. And if it did, then that would be my fault, right? Management doesn't consider that. Management doesn't care about that. Management only cares about input and output. So if management sends me an A, they expect me to send them a 4, because there are 4 A's here. And if they send in a B, they expect 5 B. They expect a 5. Right? Because there are 5 B's. They send a C, they expect a 2, and if they send an X, they expect a 3. So I can actually take that information and just sort of copy it down before we ever even start. I can do all that calculation beforehand. And I don't have to actually calculate anything. I just have to figure out which of the 4 things this is. Is it X? Is it B? Is it A? Or is it C? That's it. That's all I have to do. And so I spend a decent amount of time, you know, just taking these different numbers and working with them in order to put stuff where I want it to be. And as you can see here, I've copied 4 into the spot I called 4, copied 5 into the spot I called 5, copied 2 into the spot I called 2, copied 3 into the spot I called 3. Here, there was an inbox. It had X here, right? Because I did copy that down here, just as something that I would need to reference if the... Well, I'm not going to explain exactly why I needed to reference it, or why I would need to reference it. But basically, this is an X, right? I needed to keep that in mind. So, I take it, I copy it to that position, then I subtract C. And when you subtract 2 letters in this game, it gives you how many letters exist between those two. So like C minus C is 0. C minus B is 1. C minus A is 2. C minus X is like negative 20 something. Like negative 21, negative 22, something like that. Maybe negative 19, I don't know. Point is, if I subtract C from something, then it will be negative if the original letter was A or B. And it will be 0 only if the input was C. So if it's 0, and if it's neither, then that means that the number is X, or the letter was X. So if it's neither, then it copies from 3, because there were 3 X's. And then it outputs that. And then it jumps back to the beginning. And if it's negative, no. If it's 0, that means that it is, in fact, the input was C. So I simply copy the 2 and put that into the outbox. But if the result was negative, then that would mean that it could be A or B. So I copy from position 15, I subtract A, and then when I do that, instead of having to stop to consider, like, okay, well, is this, you know, like, what is this, right? I could just say, hey, like, instead of actually having any sort of logic to check, hey, you know, is it 0? If so, then output 4, because that's how many A's there are, and if it's, you know, not 0, then output 5, because that's how many B's there are. I can copy it. I can copy that number into position 17, then reference that indirectly. So if the value is 0, it will look here. If the value is 1, it will look here. And in fact, I didn't even need to, yeah, this program won't work. This is a program that I wanted to make. I wanted to use this program, but the problem is that X minus A is too large. So if I try to run this one, then once it gets to the X, this happens. The tile with address 23 does not exist. And so I couldn't just copy down the number of X's into position 23 and use this. Otherwise, the problem would have been even simpler. But no. And in fact, but this particular thing that I have here, I can make it even simpler than it is, because what I could do is I could, instead of subtracting C, I could subtract X. And then, if it's 0, then I can return, I can copy from 3. Otherwise, we know it's negative. We know that it's negative. And the number of C's there are 2 C's. So I just put a 2 right here. And then the number can't be positive. It must be negative or 0. So I can just if it's negative, it will jump down here. If it's 0, then it jumps down there, which means that those don't do anything, which means that this doesn't do anything. Jump if negative comes down to here. So I copy from here, I subtract A, copy it to there, perform an indirect reference. So if it's an A, it will find a 4. If it's a B, it will find a 5. If it's a C, it will find a 2. Push that into the outbox, and then jump back. I had somebody once tell me that computer science is the art of maximizing the amount of work not done. And I think that this solution to this particular problem really encapsulates that quite well. Because how many times does the computer, how many times does my little person in this episode, in this level, ever actually calculate how many of something there are on the floor? The answer is 0. She stops and figures that out a grand total of 0 times. And frankly, I think that's pretty swell. Because that is what we call, what do we call that? Like a compiler time optimization or something. The point is, right, that this is actually, I did all of that work before I ever even ran the program. Before the program ever started running. I did all of that work. And it's perfect. Now this, what you'll see is that this inventory report actually says that my best completion is in 45 steps. The previous program was slightly more efficient in terms of speed. However, it also used it was also significantly bigger because it had some extra jumps and stuff in it that didn't need to be there. So overall, yeah, the size is bigger than the ideal, specifically by 6 commands, which ultimately is not that much. But look at that speed, right? The speed challenge, right? This is supposed to be hard mode. Can you get it to run this fast? Is 393 cycles. Here, with this program, I got it in 46. That is crazy, right? That is less than an eighth of the supposed gold standard. And I am insanely proud of that. So, anyway, I think I'll end this video with this. And, you know, if you like this and you want to see more content like it, you know, then push the like button, comment, subscribe. And if you didn't enjoy the video, like anyway, I could use the publicity. And as always, take care, and I will see you next time.